Fantastic. Should we let people get in first or?
Yes, so
Okay.
welcome everyone. This webinar is hosted by the ibpsa-usa. If you have any questions during the live session, you can submit them at any time in the chat. Simply click on Q&A icon at the bottom of your screen. First, let's welcome Afonso Hernandez to introduce our project StaSIO.
Fantastic. Thank you, Wanzu. Yeah, so my name is Alfonso Hernandez. I'm with Gensler, but I'm also part of the Project StaSIO team. And for all of you that don't know us, Project StaSIO came to be as a initiative inside ibpsa USA, essentially about how to visualize data and how to ask the right questions from the models and from our clients and client architects. So we essentially started gathering data and gathering studies to make that that visualization of that data a little more understandable and essentially help us frame the questions to the problems that we have in every building. So um, and questions that pertain to quality, the quality of the projects, how each project can be optimized in terms of quality and also in terms of the physics of each project, but also about the numbers, the how those projects can be optimized in terms of uh, money, energy, anything that could be quantified and optimized that way. So this is us. This is Project StaSIO, which is a few years old. We have a board of which Guangzhou and Michael, who are also part of this call, are part of, and we have a website. If you want to check it out, it's Project Stasio at projectstasio.ibepsa.us. We also have, as part of our initiatives, an annual challenge. You're all welcome to send your ideas and how to present those ideas. And we have an annual challenge coming with a deadline of March 13th of this year, which is next week or in 2 weeks. You're welcome to submit your work on how to um, present these ideas, and we'll evaluate those, and tell you who the winner is. We do that competition every year, and this one is coming, and the winners will be announced at the ibepsa US at the SimBuild conference in May. Also, we have a webinar coming, not a webinar, a session at the ibepsa conference, at the SimBuild conference, uh, that will talk also about how to visualize data. So with that, back to you, Wanzu.
Thanks, Alfonso. Nowadays, game engines are transforming building design and the way we are thinking about building simulations. In this webinar, Patrick Peace, Associate Principal and Building Performance Leader, together with Eric Nari, Computational Design Lead at Borough Harport, will share their expertise at the intersection of design, analytics, and game engine. Welcome, Patrick and Eric.
Thanks. We're excited to kind of dive in and share out what we've been working on with some game engines. I'll let Eric get the screen sharing, and then I'll dive into some introductions before we go through some very exciting, I think, case studies, and we'll show some live demos as well. Perfect. All right. So diving right in, as I mentioned, we'll do kind of a quick intro on why we like to think about game engines and some of the workflow. and then try and spend a lot of the time here today talking about some case studies that Eric and myself have worked on, kind of sharing out some lessons learned around using kind of these powerful 3D visuals. And then I think we have a good amount of time for some Q&A later that Michael's going to host. So we'll go through all of that. If you want to jump forward, Eric. Um, so kind of setting the scene, why are we talking about game engines? The big driver for us for game engines is really around decision making. How do we reach our clients, whether they be an architect, whether they be a building owner, building operator, to get to a decision point on some complex things that we're all dealing with, whether it's energy optimization, daylight, a structural design choice, things like that, faster. And that's why we're really, using these powerful visuals to help us, going beyond a graph, going beyond the data, and really having a more immersive experience is really a big reason we're, exploring this. Game engines as well, they're great at understanding trade-offs, especially again, if that trade-off is something visual, perhaps our highest energy efficient option actually has pretty poor daylight. That's something we can say, so we can put in a graph. But if we can bring someone into the space and kind of, have them visualize, it's much more impactful. Um, and another thing that's really nice about game engines, it allows you to some degree, answer questions in real time because you've created essentially this design space and this environment that, if a person in the room has a question, oh, what's going on in this corner, that's very important. You can move over to that corner and kind of experience the space from there. So really kind of speeding up the time between a question and an answer is a really powerful tool within game engines. So the workflow that we've continued to refine, but I think have in a really good spot within Burl Happel is really threefold. First is what we like to call the ideate phase. This is really all about collecting the questions. What is important to everyone in that room when it comes to the things they want to know about. So is it as simple as what's the best HVAC system? What massing is going to be the best for energy costs? What's the impact of the envelope on costs, on comfort, on things like that? And these questions we like to kind of collect via a kind of a working session with our clients to really understand that brainstorming session, all cards on the table, no bad, no wrong questions, so that we can define essentially this idea of a design space, these options that we want to consider that will help answer these questions. So that's the really important kind of first step is, what do we care about and what do we need answers to? The next thing we need to do, kind of similarly within that same workshop, is then talk to say, okay, these are our questions. How are we going to answer them? What's an answer that will be recognizable to the team that will allow them to make movement forward, make a decision. And so this is going to be things that are quantitative that we're going to directly simulate, things like energy, things like peak load, things that we could calculate from that, such as first cost, operating costs, embodied carbon, the hard numbers. If those are the most important things, we want to have them, or we want to measure them and then put them into this environment. But we also want to talk through what else matters. This is kind of the qualitative. Not everything can necessarily be a hard number. Things like daylight, user experience, just the space things take up within a volume, constructability even, are all things we want to consider. And so having that conversation with our clients to say, okay, what layers can we put on top of this that we can help build into the visualization? So that's a really good understanding, and we grow confidence through the game engine to have that decision maker decide between A and B, but have confidence they've made the right decision because we're able to visualize all of that is really important. And so once we go through essentially that ideation, that measurements, of course we run some simulations which we'll talk about. But then the really nice thing with the game engine is this whole exploration phase. Now we can be in the environment. We can play around with the controls, which we've set up, which is essentially, those measurements and options we've discussed, and just start to understand, okay, what's changing? What can I learn from this? And we can do that both, internally, so we can get a story together. We can do that with our clients, and they can ask the questions and start to explore it. And again, it's really about, you know, enabling clients to reach their decision points by answering questions, in some case for themselves within the environment, so they have the confidence to move forward. So that's an overview of kind of the three main steps. Just a bit more about our approach to kind of the game engine, interactive application in general. It's really consistent of, six key components. There's the 3D platform itself, which we use to render all of the environments. It has a really great ability for real-time rendering of the sun and shadow at any given day of the year, which is a really great, advantage to this type of environment. And then we're able to plug in a lot of interesting visualizations, whether that's physics and daylight based, whether it's CFD based, so kind of immersive analysis, and all of that can be integrated with a user-friendly interface, additional data viz within that as well. All of that is essentially plugged into the singular application, this platform, which really becomes a decision-making platform for us. To share a bit about the workflow that we have that enables us to do this, the analysis that goes into these game engines, it's really the same analysis that I would hazard that several people on this call do day in, day out. It's things like using IES, it's things like using Ladybug tools, OpenStudio, Radiance, all those types of tools to generate the simulations, to generate the data. We then use the BOM, which is the Building Habitat Objects model, which is an open source kind of modeling schema that allows us to translate these things essentially into meshes that we categorize as the various options that get loaded into the environment. Essentially, this Unreal actors that then can connect through and speak into the game engine language. And a typical workflow allows us to build out things like we see here in a very templated way, where we're connecting in data directly into metrics, we're connecting in options into pre-built essentially settings. So everything's essentially templated in a fashion that we can take, what is, on the face of it, a lot of really dense data, pull it into a system that has some rules we predetermine to allow that to go to, a client very quickly, and everything's kind of prepared in a standardized way, allowing us to do things like display data, display plan views, work through options, look at different environment settings, all of that in kind of a pre-configured user interface. So that's a bit about kind of the workflow and kind of the why of game engines. Now we're going to pass it over to Eric, who's going to run through some really exciting case studies and then actually a live demo as well.
Yeah, thanks, Patrick. So we've been doing this for a while now. The general approach that Patrick described is definitely extensible to just about every discipline we touch. So we've looked at using this for everything from structures to building physics to city scale, quite a few applications. We're going to look mainly at ones that are building physics related today. The first one I want to start with is the first one we started with as a pilot project for this initiative as well. And this was a project we were doing in the UK for a space that was kind of prototypical for where you'd be exploring a design space of shading versus glazing selections versus daylighting and trade-offs between daylighting, overheating, how much daylight's the right amount, how much is too much, how much do you have a view if you just shade everything, exploring all those trade-offs. So this was a really good application for us to bring into the game engine, make those decisions that Patrick was talking about. So we were able to overlay all those different analyses for different key options that were being considered. Look at how those performed, look at what the space was going to feel like, And then again, the key here being we could explore, we could walk into this space, we could see what it really was going to feel like. We could see from the analytical layers where there were going to be issues depending on the different options, so that we could quickly understand where this was good or bad for the floor plate, where that related to different program. And then also looking at simple things like cutting out holes in the floor for skylights to bring in more daylight for the classrooms below, to really appreciate the impact that might have. So this is what we came up with. And the background of this, just kind of speaking about what enables this, Patrick mentioned Ladybug tools. A lot of what you see in this specific use case was parametric studies done via Ladybug tools initially, and then a few other simulation engines for analysis as well, which we were able to then bring into the game engine and explore. So that's what you see here. Again, the fact that it's very visual, we're able to see visually what these look like versus the trade-offs of the different key metrics, became a really powerful tool. And from that, the next evolution with that team was a project that was looking at over 2,000 options. So again, the parametric analysis approach was critical. And then being able to make decisions. I'm sure a lot of people on the call have seen parallel coordinate plots before and use them to make decisions with these kinds of trade-off studies and wide parametric studies. But the nice thing here is instead of just doing that in isolation where it's just the data, we could see as we look through each of those datas on the parallel coordinate plot and saw the outcomes we wanted to see. We could also see what that looked like physically. We could see how that impacted window shapes and sizes, operable versus non-operable windows, and then look at specific spaces. So if the client wanted to explore what that was really going to look like on a typical room in the south facade versus a meeting area in the west facade, we could do that, and we could look at each of those spaces and understand not just from a this one option is better at all these things and that's it. We could actually get more granular and explore on a space by space basis and really understand how the space was working for us. So here's some examples of that in usage. This became a pretty useful tool again for us to be able to explore, make decisions, and then critically move forward. Is make decisions with confidence so that we could say, okay, here's the few things based on this that we want to proceed with. We're confident that these are the right decisions, and now we can move to the next decisions that need to be made. The design can evolve from there. Just a video of what that looks like. Again, you can see that as we're looking at these range of different options, we get the visual. We see what the facade's really going to look like. Then we can understand what impact that's going to have on those openings across the facade. We can go onto the floor plate. We can look at how much sunlight it's going to get into those critical spaces. We can also just hour by hour, because it is a game engine, it has a sun sky system. We can see where the sky's really going to be at certain points a day, what that's going to look like at 2 p.m. on a typical June day, for example, versus in the winter, and just better understand how the space is performing across these different options. Just jump ahead to where we've got the data viz here. I don't know if we have it in this video. Yeah, there we go. So you can see, looking at all rounder, so like seeing a couple presets. I also just want to touch on this with the presets here. One thing that we found useful was having some of these preloaded options. So instead of just exploring 2,000 options freely, we're actually kind of guiding that conversation to say, here's the 10 prototypes that are worth considering based on client input, the team's input. So we're not wasting our time looking at all 2,000. We've already kind of pre-selected some worth considering, and then we can make the decisions from there. From there, I'm going to go into a couple other kinds of analyses that we've done in this space. CFD has been a really critical one. I think if anyone on the call has dealt with CFD analysis and outputs, the kind of static 2D outputs never really do it justice. So this is one where we kind of said straight off the bat, we need something interactive. We need something that you can explore that's more intuitive for understanding how airflow is really working in the space. So we played with a couple different ways of representing this in the game engine. The nice thing about game engines is you can have particle systems, you can have object behaviors, you can do all kinds of things beyond what we could do in our typical workspaces using Rhino, Grasshopper, IES, all the like typical simulation engine static outputs. And we can customize these behaviors too. So depending on what we need to understand about that analysis, we can cater accordingly. What that led us to is again a nice output where we're able to dynamically look at different options. In this case, being able to understand how active systems are working within a large atrium space to move airflow and how much that's actually impacting the comfort plane. Are we achieving comfort during our peak load scenarios? Where is it still going to be too hot due to operative temperature because of mean radiant temperature of surfaces, for example? And atriums, this pretty critical piece is you get a lot of sunlight coming in. Even if you're conditioning the space where it's technically comfortable, a lot of spaces within there might actually not be comfortable. And you also don't want to inefficiently just condition the top part of the atrium, obviously. So understanding the CFD there is really critical. And then looking beyond just internal, but also external, being able to understand on a more multi-disc level externally how we create comfortable spaces. This is something we've been looking into more recently in the game engine space because it's a pretty critical way to explore this information, is being able to say, how thermally comfortable is an outside space, but then also based on things like people flow analysis, acoustics analysis that we're doing. Does it really matter if everything is thermally comfort, or is it just critical to have things thermally comfortable where people are moving through most often? And also understanding if an area is dense, for example, it's going to feel warmer than an area that's unoccupied. And how does that further impact thermal comfort and user comfort? It's just an example of one of the projects where we've done that, where we've looked at what does an external space look like from a comfort standpoint. Again, being able to bring in CFD, bring in operative temperature, all these different layers to understand what is that space really going to feel like. And this is some work that we're really excited on expanding on for the external space, looking at passive comfort strategies and how those can create more comfortable external spaces, and then also critically prioritizing where we need things to be more comfortable, how that could guide programming or even design of these external spaces on a campus scale. And then a couple other kind of targeted case studies where we've done building physics, facade analytics. This has become our pretty standard set of analyses and a deliverable that we've done quite a few times now. And the nice thing that Patrick mentioned is we've started to template this stuff. So it's not some fancy pay a bunch of extra money and maybe you'll get to use it. It's not something that we're only able to use on giant projects. We're able to lock this in with our other workflows, with our other analysis as a standardized process, bring in different analyses, bring them all into the same space. In this case, we're doing facade analytics, so things like glare analysis, shading studies from a facade, but then combining that with system strategies, different diffuser strategies for optimizing airflow, for example, and then improving comfort on the comfort plane. Here's what that looked like. This is for a gallery space that was fully glazed in a hot environment. So we kind of knew we had to do something here. Couple different things that we were dealing with. How much sun is getting in this space. That perimeter area especially is going to be too hot. That just goes without saying. And then looking at the system as it stood, this is a renovation of an existing space. So being able to say, with the current scheme, what does the airflow look like in this space? What is the estimated comfort? And basically identifying and validating the experience of the users, that it was too hot at certain points of the year, and that a lot of the floor plate just wasn't able to get used for exhibitions and other things they wanted to use it for. And then based on that, saying, okay, here's some proposed alternate systems. Here's a proposed solution that will solve a lot of these problems. And also being able to do different levels of that. So to say, you could do a slight revamp of the mechanical and diffusers and get substantially more comfortable, or you could add additional shading and beyond thermal comfort, also get a visual comfort benefit, and helping the client make those kinds of decisions in this interactive space. And then another similar example, this was one of these large atrium spaces. Again, this is a pretty common space that we do the CFD analysis on to really understand how comfortable is the occupied space and what is the most efficient way to condition it. Also then using that to guide things like what kind of glazing constructions might we want to use. So in this project, the SHGC was pretty critical because of all the heat gain we get from sun coming through that atrium for the high summer sun. And if you can see in this video, or in this image rather, go back, there we go. This image on the back area where there's the where the sun gets through, our operative temperatures are a lot higher. This is showing MRT. So again, surfaces are a lot hotter. Hotter surfaces means you're going to feel hotter, even if technically the air temperature is 72 and you're conditioning the space, it's still going to feel much hotter. And that results in negative thermal comfort. So when people talk about UTCI, that's the kind of bread and butter here is it's not just about what is your dry bulb temperature in the space. It's not just about are you conditioning the space based on the amount of mechanical load being enough to cool the space. Technically, like you actually need to understand airflow and radiant temperatures to understand what that space is going to feel like for any of these complex spaces. The game engine gives us a way to communicate that and to explore those results in a much more dynamic way. And then I want to follow up with one of them I'm going to show a live demo on. We might do an additional live demo too. We'll see about time. This is our adaptive reuse initiative. So this is kind of taking everything that I've just shown and spinning it all together with the ability to look at an existing building and say there's a bunch of different things we could do with this building. Based on all the different things we can do and all the things that we've decided we care about, to Patrick's point of starting with asking, what's important to everybody? How do we measure what's important to everybody? Having the scoring system of outcomes that then relate to a score per option, and being able to use that to say for a bunch of different options for this adaptive reuse project, how are they scoring and what kind of decisions do we want to make? What do we want to do with this building? And this is something that can start very early on and then guide further decisions as more analysis is done as well. But you can see here we're looking at different options. First of all, just physically, what is the building going to look like if we add a few floors? If we try to maximize floor area that we're adding, if we do light touch and just keep everything that's there and maybe just add solar. So you can see us looking through a few of those different examples. Again, of course, you can explore different times of day, which is helpful just to understand, where's the sun moving through the space, how are the floor plates behaving, and then that'll guide your facade design for different opening sizes. Here you can see we go from the existing building to a few other options. In this case, we're showing the structural modifications, first of all, for different structural options for how we add to this building. Also accounting for possible structural reinforcement that's going to be required on columns below. Obviously, that has a cost and embodied carbon implication. And then from there, jumping to different analyses like floor heights. So if we're adding new floors, do we have floors that are a different floor height that might be useful for different program? Solar energy, so what is the solar capabilities of the different options? How much roof space do we have? How much is that roof space actually getting access to sun? You can see some of these panels in yellow aren't getting as much sun. So understanding what kind of potential we have for things like solar analysis as well. And that all kind of feeds into the embodied carbon and the energy pieces of our outcomes here. And then based on that, being able to look at a few different viable options and make decisions on which one of those we want to move forward with, based on cost, based on what performance do we care about, and what performance maybe are we willing to now make some compromises on based on what we're seeing and where those trade-offs are occurring. So I'm going to hop into a live demo of that, and then from there, I think we'll open it up to some questions, hoping that when I hop into this live demo, the Zoom screen sharing behaves. So I'm going to look for Patrick to give me a thumbs up once this is up, if it's on screen. Do we see it?
Yeah, that's looking good.
Wonderful. Okay. So this is again what the adaptive reuse application looks like. Another nice thing here is that we're using a plugin called Cesium, which I don't know if people are familiar with it, but on the call, just a good thing to be aware of is that technology in this space has moved really fast, really quick. So you can now load in basically anywhere in the world. You can use what are called 3D tiles from Google, or there's a bunch of other sources of where you can get in this 3D information of the planet, essentially. And you can combine that with real sun sky systems. So even if you didn't bring in any of your own geometry or anything, you could just jump into anywhere in the world and like see where the sun is at different times of day, what trees and buildings might be blocking the sun at those different times. Like there's all kinds of really cool stuff you can do with this just straight out of the box. But in this case, we're bringing in all of our different analyses, bringing in our different options. So if I look at let's start at existing, I'm going to look at just the solar assessment. So here we have the different assessments that we want to visualize. So along with seeing the data from each assessment, we can see visually, those heat maps or whatever other representations. If we had CFD, we can see the CFD streamlines. This is where we get that visual representation of the different assessment layers. So if I look at solar energy, for example, it's the existing building, doesn't have any solar. There's no solar generation. That corresponds to the fact that the energy score is quite low at 30. But of course, the embodied carbon as a trade-off is quite high because we're not adding anything. We're not touching this. The embodied carbon is essentially 0. You might ask why it's not 100. 100 would actually be if we're reaching negative, which certain schemes could reach negative. If we look at option 1 here, we're adding 1 floor, we're adding solar. So you can see that now we see some solar energy being created. There's additional embodied carbon costs, but there's a big energy benefit now. Spatial quality is also starting to increase. And if we look at some other options, you'll see how these different metrics vary accordingly. If we look at like option 10, for example, which was our top performer, this is, again, I will say top performer in this case was based on what our questions of what mattered most were and how we weight these different outcomes. Of course, the top performer is going to depend on what those different outcomes are. And this is where it's nice that we're able to explore and able to say, if we just care especially about daylight, this is actually our option that gives us the best daylight performance. So if I look at our SDA and I pull the facade back, I can see that the facade, because of large window to wall ratios, nice clearance heights on these new floors, this is giving us a really nice even distribution of well daylit spaces within. And then we can also do things like, again, looking at these different utilization metrics. So understanding from a structural standpoint, for example, column utilization, are we efficiently using the columns? If we add on more, you can see some of these foundations start to go to yellow. Fortunately, this existing building was over-designed, so we were able to still use the existing structure. And it was nice for us to be able to capture that in what we call our structural feasibility metric, as well as cost. So that's these different assessment layers, how those are performing. We also have different features for being able to look at a section of the building so that we can see those different floor plates. For example, if we want to look at this options SDA within there and see, as you get deeper, you get a little bit less daylight in this space, so we can quickly understand that in an intuitive way. We can look at the facade and see how that's playing out. And just, this is where we get into that explore space. If we wanted to look at a floor plate and really understand, just go to none and start walking around. We can walk around the floor plate as well. So nice that we're able to just see, okay, based on this scheme, what is that going to look like? And as I change to these different options, you can see we can immediately understand the change of the different windows. We could also hop over to this facade maybe, and if we care about views, and that's something we want to understand, we can critically also look at these different views and, when we make the windows narrower, how does that impact the view? And then in the existing building, we could similarly go into the space and see how it is as it currently stands. So a really powerful tool for us for decision making, for exploration, and for kind of workshopping and figuring out what have we done so far? How are things working so far? What kind of decisions have we made, and how will that guide future decisions? But then also saying, okay, let's make decisions based on that and move forward. And what do we want to focus on moving forward as well? And it's been a really powerful tool to make those kinds of commitments to, okay, we now understand what's important moving forward. We know what to focus on, and we can continue to make those decisions quickly as a team using this platform. With that, I see a few things popping up in the chat. I imagine that'll be kind of our precursor to Q&A. So Michael, maybe this is a good segue into Q&A. If there's already enough questions, I think we might as well leave some time for that.
Yes, I would. Yeah, there's been some good questions coming in. I can jump into those. There's a few that went in the Q&A and a few went in the chat. I don't know which ones you'll be able to see, but I can read through them. The first one we had was a general question. With AI integration within new graphics cards, how does AI come into play with attempting performing parametric example, varying glazing, sodic gain coefficient, visual light transmittance, or varying envelope thickness, studies using the game engine itself? Has that, I guess, that played any part of it? And there was another question along the same lines about the engines used for simulation versus the gaming engine used for visualization as well.
Yeah, loaded question there with the AI simulation part. I can touch on, Patrick, maybe we both tackle this one because there's two sides of it, right? You want to start with the simulation side?
Yeah, I can start with I guess some of the simulation sides. So with AI, I think I think this kind of gets back to the process where we want to define who are asking the questions, what their questions are, and what we want to look at. I think the inferred, advantage of AI is, you could do a bunch more iterations, have an agent go off and do them all. But really, we're not trying to do thousands of iterations. We're trying to do the 10 that matter. And that's the really important part here, is establish what are the 10 that matter. As Eric showed too, you can then bookmark them, things like that. And those are what you want to talk with the client on. Clients don't necessarily want to see 5,000 parametric runs, because really they want one answer out of that 5,000. So establishing what actually needs to get studied, I think, is the really important part here. Instead of kind of releasing an agent to go off and study a million different things. That would be kind of my recommendation on approaches there.
Okay. Let's just see if there's any other ones that are along that line. One was specific about the rendering engine you're using. Like, how is this engine different from other real-time 3D rendering software like Enscape, Lumen, and D5?
Happy to tackle that one. So it's all about the interactive piece. If we look at Twinmotion, we use Unreal as the basis. That's our primary game engine. We've used Unity a bit as well, but Unreal's the one we use primarily, which I think was one of the other questions too. So can knock that one out. But the thing is, it's all about being able to be interactive, being able to have behaviors, being able to have these custom kind of connections between raw data and how you explore it. Enscape and D5, for example, are just going to show you an image of what you have and then let you move around that model. It's walking through a model essentially. And early days of Enscape, we did some kind of simulation mock-ups of bringing in analysis results. And the thing was, because we couldn't customize it, we couldn't bring in CFD and make it a particle system. We couldn't get a heat map to look quite the way we wanted it. We couldn't walk around that floor plate and get a metric on the UI that tells us what the operative temperature at the exact location we are is. We couldn't get all those kinds of next layer behaviors that we needed to make it a tool that we could use in a meeting effectively. So we still use Enscape a lot. Enscape's awesome. But Lumen D5, they're all great. Twinmotion's great, but for what we use this for, it's not really fit for purpose, because we use Enscape, for example, if we're trying to do a walkthrough of a space and just understand what the space feels like visually, like spatially. It's nothing about the analytical layers. You don't understand the estimated EUI based on different facade configurations of a space by using Enscape. So yeah, just a different use case and a different tool, but tools that are all built on a lot of the same foundational technology. So there's that.
I think I have one question on because you're talking about the interactivity of loading the results, right? And then like the top 10 things the client wants to see or have questions about. There were two questions related to that. One was on dynamic materials, such as dynamic tinted glass, that could respond to sunlight on it. Could that be incorporated into the game engine model? And the second one, which is similar, just about being pre-baked or not, right? Are all of the results pre-simulated, and it's really a visualization. So it's not real-time simulation, more of a game engine for visualizing the results you've picked.
Yes, these are two fantastic questions, and two areas of interest that we're exploring right now. So first one, absolutely yes. Material behaviors in Unreal are pretty easily linked to parameters, let's say, or just values, variables in your project, which would include sun intensity. So absolutely, yes, you could simulate that. One thing to note is that if your solution is an adaptive solution, sometimes your analysis is less compelling then, right? Because your analysis isn't telling you where you need different treatment. Your analysis is just reflecting the fact that your solution is adapting, and your analysis becomes more of a flat heat map. So something worth just noting there is that in that case, I think what we would use the game engine for is exploring how the material is changing rather than exploring the resulting analysis, if that makes sense. And then to the point of real-time simulation, this is a huge space we're looking at right now. It also slightly ties into the AI question previously. Most of the analysis Happold cannot be done in real time yet in an accurate way. Some of it can be done in a way that's kind of fuzzy accurate enough for early decisions. And we are looking at different ways of doing real-time simulation for those things. PV potential, for example, solar potential, you could move solar panels around and immediately see an estimation in the game engine. That's already happening. But the CFD, long way away from being able to do CFD in a game engine in real time. As it stands, we use really heavy cloud-based solutions, and it's still not real time. So that's something that is preloaded. Similarly, daylighting analysis, you've got millions and millions of data points for if you're looking at a typical range of analysis meshes at a decent resolution. Not real time. But the nice thing is game engines do really good ray trace calcs and all kinds of optimizations there that we can tap into to get some information in real time. And so we're looking more and more at what we can do in real time that's more of like as you change the design or as your design evolves, you get that immediate feedback versus you still have to run the analysis, but you have a more efficient way of running the analysis and then bringing it into a platform where you visualize and explore.
Cool. Thank
And
you.
and I could that could be a session all in itself, just like the future of game engines, and I'm sure everybody's familiar with Autodesk moving towards Forma and some of the kind of movement in that space. But like within the next 5 years, we're we're going to be working in some form of game engine type platform for real-time analysis where you do get some of those answers and where those answers get better and better.
I guess tying to that about answers. So I wanted to basically ask the question: have you had the opportunity, I guess, after a building's been constructed, to be able to verify the design choices delivering the desired results in operation, and then using that to potentially enhance the modeling or like scoring system that you have to recalculate the indicators for your building operation?
I can take the first part of that and then hand over to Patrick for all the hard part of that. So the easy part of that question is the scoring is not based on any like real singular answer of were we right or wrong about the building. The scoring is taking metrics that are just the analysis, which I'm going to let Patrick talk about, and then adding weighting based on the team's priorities and what decisions they want to make. So there's no way you could really post validate that other than just asking the client, like, are there certain things you wish you had weighted more? But that weighting is a matter of personal preference and is something that changes project to project. However, the underlying analysis is very much not a matter of personal preference. And Patrick, I'm handing off to you for that.
Yeah, absolutely. I think the the goal of collecting data from the actual built asset is definitely something, again, I would hazard that several people on the call are always trying to do. It does become a contractual challenge. You know, projects get built. Sometimes the designers are no longer kind of involved during operations. So that becomes a hindrance. But we have had some great luck and I would say great opportunities to work on some living building challenge projects with clients. And those are great projects because we are involved in operations. We get to see some of that data as we go for LBC certification. And those are great examples where we are then allowed, able to use that data to check back, did we get our, annual monthly energy estimates right? All our daylighting, turning down as much as we estimated. So we do have some examples of that from some of those projects. And I think they have, in some cases, helped to redefine how we do predictive modeling. Lessons learned go into the next predictive model and help to define those processes. So it's definitely, I think we all wish we had more data to learn from, but we're slowly learning from the limited data we have.
This is something I've in my experience from 3D visualization tools, especially when they're like spatially laid out. It's great to see some more interactive CFD visualizations coming out. And this is another great example of that. And like spatial data is great for lots of people who learn different ways, right? Like recognizing room, this is an office, I would sit here, and then they can see the data on the space. Makes it much easier. And it's always about reducing the leaps of faith for the person to not so imagine X and imagine then Y and then imagine then Z and then this thing would be better for you. Instead, you can show them, bring them closer to that decision point to make them make that decision. Have you seen that? Any reactions to this live been better, like in presenting data that you've seen from clients and like being able to make better decisions based on that?
Yeah, I can start, and then Eric, I'm sure you have some good kind of examples. We've definitely seen some aha moments through using these tools, especially unlocking things we didn't know we were gonna deem very important. So on a project we worked on last year, the focus was on at first kind of daylighting for interior of the building. And then through exploration, we actually realized that some of the exterior daylighting, the sun hours for some of these courtyards within the design became very important. And this was a kind of an aha moment for the design team to say, well, we want people to be able to use these courtyards as community spaces, things like that. How we get more sunlight into them to activate them more. And so definitely it kind of pivoted their thinking to what did matter to them. What they thought was X became Y. We helped them explore that. So I think it was a really exciting outcome.
Yeah, I think along the same lines, we've had some very early stage outcomes like that where maybe things that would have been obvious if somebody had considered it but hadn't considered it yet. And then in the game engine, when we're looking at here's, expected daylighting of areas, or for your existing building, here's structural feasibility of certain areas. Like it it unearths some of that early on, which can lead to some good decisions being made that might have gotten missed later. And then we also have, like, on a more granular scale, when we get to maybe DD phase and we're looking at questions of, very targeted questions at that point, which is a benefit, is saying specifically, what if we look at three different sizes of windows and three different SHDCs and three different shading configurations, and we know we have X amount of dollars to spend on this. What is the way that we maximize daylighting and minimize overheating risk, for example? Like, some of those really targeted questions lead to some really good outcomes too, because then it's just like you make a decision, right? The question is clear. You can look in the space, you go in the different spaces, like you were saying, Michael, to like spatially see, like, is that going to feel right? You're not just saying use small windows to reduce overheating, and then they're like, well, that's not going to be a nice space. You can actually just go into it and be like, okay, this is too small. This is small enough. This shading is actually kind of neat because of this affected creating's just not working. Like, you get that done quickly. And I think we've seen some really good success at that stage too, where otherwise those decisions kind of just, you kind of chase your tail. And I think I've seen the good and bad version of that, where the good version is you make a really good decision and you move on and it's successful. The bad version of that is you feel like you've done the same analysis 100 times over and over and nothing's actually happening. And this tool makes the good version happen more than the bad version, I'd say.
That's pretty good to hear. No, I don't see. I don't think we've got most of the questions from the chat and stuff, but I have a couple other ones
Yeah.
that I had thought about. One was on like you showed, so the data is pre-simulated based on like client questions and your own design engineering judgment. The layout of like daylight on in the 3D space, I noticed that most of it was on the floor. And then obviously you can calculate at different planes, right? And then obviously with comfort and CFD, the plane of the measurement of the radiant temperature or the surface temperatures you mentioned with the flow, have you had challenges in trying to incorporate because like the CFD gives you data every cell point, right? So which ones to use, right? Which ones to present to the client.
Yeah, so I would stress, for the different kinds of analysis that we do, we kind of have different embedded behaviors for each. So for the daylighting, for example, there's kind of a default in the template that we're going to do our analysis at a comfort plane, but we're going to represent it upon the floor just because of navigation. It makes it easier. Whereas some other analyses, we're representing exactly spatially where it occurs, such as
Right.
the CFD, the streamlines. So that's on like it depends on the use case, how we represent it. And that's another nice thing about the game engine, is if we decide tomorrow that we want to represent it a different way, it's basically an embedded behavior within the template to say, when we bring it in, set it to this height
Place
instead.
it at
Or
three
when we
feet off the ground, right.
yeah, or like one change we made at one point was we decided all of our heat maps for like all of our like thermal heat maps should actually be slightly transparent, because they were reading too heavy when it was opaque, and it was just like the feel wasn't quite right. And we were able to just say, like, okay, what's the right transparency number? And it was literally just saying in the template, is it 0.8 or 0.6? And then that's how any of that kind of analysis gets represented. Same idea for the streamline, saying like, how fast do they need to be? What should the coloring be? Like, it's a really nice way to be able to dynamically control that. And it does mean for each of those different spatial analysis conditions, we can get it to feel right, even if that needs a little bit of modification beyond just the raw data that you get from the engine, from ANSYS or from IAS or from wherever else it's coming from.
Nice. It's certainly I always thought about is reducing the leaps of faith by whatever's accurate enough to get people to make that leap. Right. So like it's not physically accurate rendering in lots of cases in gaming engines, right? There are lots of shortcuts that gaming engines use to do this thing super fast. But it's accurate enough. And if you see any things on like your wish list where you would like to make it a bit more accurate, we've had a bit of like, oh, this is a bit of like, what's the uncanny valley? Like this is a bit strange, but you'd like the engine to push further.
I've got a long list. The first one by far is lighting, because we are not at a point yet, and we've had I've had two students now that I worked with who are doing PhDs on this, and we still haven't cracked it. So that's not a good sign. But basically, even with the whole rendering pipeline that game engines use, to your point, it's good enough to feel right, but it's not scientifically accurate. We haven't been able to come up with any solution that gives us accurate within acceptable ranges estimation of artificial and natural lighting in the game engine. Because what I would love to do is be able to take a model, put it in a game engine, put some lights in there with IES profiles, which is all, physically accurate and it's all there, and be able to say, okay, based on all that, what is the light level in this space at any given point in time with any given controls? And we just can't do that yet. So that's my number one for sure. But there's a few others. There's been some really interesting work on the CFD side, being able to simulate CFD within the game engine. Every solution so far, it's the same idea. It looks really cool. It's really compelling. It feels like it might be rightish, but then when you actually validate it, it's completely wrong. So it's not really usable yet. But again, these things are only getting better.
Right. Exactly. And that's it as
I
well.
think
Lots of the longer simulation times, right? Take time to bake and then you have them, right? And you can this is easy enough with processing power available to people now to go and make these options that you can read in,
Yeah.
right?
And it's just computation. Like at the end of the day, any of these things we're showing is ultimately just a bunch of different calculations being made with different kinds of inputs and outputs. So some of them can be done in real time already because there's less calculation involved. Some of them can't because there's more calculation involved. And if somebody comes up with some really clever algorithm for doing CFD analysis for something that currently takes 2 seconds and it takes 0.1 second, maybe tomorrow we'd be able to do it in real time then. So it's just a question of when these developments happen, or until they happen, how we get things that are good enough.
Okay, I know we have 6 left. If there's any other questions from people, either throw them in the messages or in the chats. We do have one more, which is a direct. Is there any AI in your tool?
No,
Hmm.
nope,
No, probably not. Not in it yet, right?
nothing.
Jason, maybe in, as everyone's seems to be using it these days.
I guess technically yes, because Cesium uses some AI for their post-processing of data, and I'm sure the underlying tools have some little bits and bobs along the way. I'd also stress that the term AI is a generic term that people use that can mean a million different things. And technically, we've done studies, for example, with machine learning going back 30 years maybe, and technically that was all AI. So I don't know, like, is IAS AI because it has some kind of underlying models and data that could fall into that very, very big umbrella, maybe. But no, in terms of what I think that question is asking, there is not any of that kind of AI.
And then they followed up with like, but could AI be used to fill some gaps? Which I guess is about, I guess like gaps maybe between simulation
Yep.
parametric ones, which
Yep.
is like the simulation idea.
Definitely. There's good potentials there for predictive. So if you have a reasonably good model of how things are, you can use AI to fill in those gaps, definitely. If we had, so like the example I just mentioned we did a machine learning example for overheating that basically lets you predict overheating risk of spaces in a specific environment, depending on the window wall ratio and the floor plate depth. And so there's potential there. It takes a lot more effort than I think people want it to take because they think AI is going to just be like a shortcut. But I say that because AI kind of is a shortcut for data processing. So the biggest potential probably is taking messy data and making it clean data that you can get answers out of. We're looking into some ways that we manage that. And there's a lot of movement in that space for even just like general business intelligence. A lot of architecture and engineering firms nowadays are looking at how they take their typically very messy, horrible data from the last however many years and turn that into a proper project database that they can query and get information out of.
Nice. I think that's a good closing question. Is there a way we can try this engine somewhere? And because the engine, I guess I'm trying to answer for you, but it's your own process to build this, right? You have the visualizing game engine, and you have your own analysis to make the results. So you're kind of like making it. It's not really
Yes. Technically, is there a way you can use this engine? Yes, it's Unreal Engine. You can try it. You can use it for anybody who's a student or doing stuff on their own or whatever. The license is just you can use it. It's software that's out there. It's readily available. The bomb is also open source and readily available. We're doing a lot of kind of connecting the dots and additional tools and work along the way that we can't share, but it's nothing that you couldn't do yourself if you had an interest and wanted to explore more. And I would encourage people to explore more in this space because I think there's a lot of potential for there's tools like Datasmith for Unreal that make it really easy to just bring in your models from Rhino or Revit or whatever. And then there's all kinds of cool stuff you can do with data. They have blueprints in Unreal, which is analogous to Grasshopper. So a lot of people who are familiar with visual programming in the AAC industry can pick that up pretty quickly too. So
nice. I was going to ask if you leverage the blueprints in like the scripting environment in Unreal, like
yes,
map
so
data.
most of what we're doing is a combination of C++ tool stuff and blueprints, but honestly, most of it's blueprint based, and that makes it quite accessible for people at our firm too. We have a few different people who can just jump in, and even if they've never worked with a game engine before, we're able to pretty quickly add to it, which has been cool to see.
Pretty cool. It's very similar to Grasshopper's node base.
It's literally Grasshopper. Like anybody on this call who uses Grasshopper, get Unreal and use blueprints, and you'll be happy.
Right. One is, have you shared your wish list with the CZM team? I guess that's just promoting that your ideas are good and please send it to them. One more question from Pauline Abrams. Is there any connection with thermal simulation to estimate energy consumption? Sorry if the question is silly. So a connection with thermal simulation to estimate energy consumption.
Yeah, I mean, Patrick, maybe it's better for you, right?
No, there's definitely a connection. So the physics-based energy simulation tools are doing thermal simulations throughout. I think the largest connection, however, with like say thermal comfort, is also kind of connecting it to peak loads and things like that. Your thermal comfort is likely the lowest when you're at peak load conditions, highest sun, highest things like that. And so when we do these simulations, these studies, trying to connect it to, okay, how do we optimize to reduce peak loads, helps us improve comfort, and then the carry-on effect then is always improve energy performance down the line. So definitely they all interplay within these studies.
Cool.
Okay, we're almost at the end. And if you are passionate about graphics or building simulation, you are very welcome to submit your work to our annual competition. I have shared the link again here. And thanks all, and we will see you next time.
Yes, thanks, Eric. Thanks, Patrick.
Thank you.
Thanks, everyone.
Bye.